Welcome to Maths for All. I'm Aisling Flynn. This is higher level. This is statistics and it's hypothesis testing. Hypotheses. What are they? A hypothesis is a claim or statement about a property of a population. For example, 90% of young people between 12 and 18 years old have social media accounts. Okay, that's a statement, that's a claim. Okay, and it's called a hypothesis. A hypothesis test is a procedure that will test the claim that was made about the population. For example, is it actually 90% of young people? Could it actually be more or less? Was the claim above true? So we need to test it. Now H0 is the name that we're going to give to something called the null hypothesis. And the null hypothesis is the claim stated about the population, and it is the one which is going to be tested. So in our example here, we're going to test if it is in fact 90% of young people, if that figure 90% is true. And H1 is the alternative hypothesis. Alternative means the opposite or the different hypothesis, and the alternative hypothesis contradicts or goes against the null hypothesis. And it says that it is not 90% of young people. So maybe it's more, maybe it's less, but it's not 90. Okay. So hypothesis testing. So this is the procedure we will go through for hypothesis testing. Firstly, given a statistic, we can form the null hypothesis H0 and the alternative hypothesis H1. So we would just write them down. Okay, in our example, H0 says 90% of 12 to 18-year-olds have a social media account. And H1 says that the percentage of 12 to 18-year-olds with a social media account is not 90%. Okay. What we do next is to take a sample, and we use results from the sample to calculate the sample proportion. The third step is to calculate the margin of error E using the sample size n, and whatever definition of margin of error is appropriate. After that, we can create a 95% confidence interval for the population proportion P, and we know that the true population proportion P should lie between the sample proportion minus the error and the sample proportion plus the error. And to conclude, if the proportion stated in H0, in this case 90%, falls within the interval, so inside the interval, then we fail to reject the null hypothesis. So we can't throw it out, we can't say it's not true. If the proportion stated in H0, so if 90% falls outside this interval, then we do reject the null hypothesis, and we accept H1, the alternative hypothesis. Notice that we can never accept the null hypothesis completely because we can never be 100% sure. Our confidence interval is only at 95% confidence. Okay, but so the language used instead is we fail to reject the null hypothesis. In some questions, the term 5% significance is used, and to relate that to what you've already seen, you may be asked to conduct a hypothesis test at the 5% level of significance to investigate a statistical claim. Previous to this, in our hypothesis testing, we've created 95% confidence interval. This means that there's a 5% chances of us getting it wrong. So what this 5% significance refers to is those two small sections at either end of the normal distribution that are more than 2 standard deviations from the mean, which is, so you have 5% outside those markers, +2 and -2 standard deviations. You have 95% inside. So really they're referring to the same thing. So if you take your normal distribution, +2 sigma, -2 sigma. So we'll accept anything that's in here, that's 95%, and we'll reject anything that's out here and out here. So together they make 5%. Okay, let's do an example and put all of that to practice. An engineering company states in its literature that only 20% of its products experience a problem within the first 5 years of use. To investigate this claim, you sample 400 of their products and find that 98 of them have experienced a problem within the first 5 years of use. Use a hypothesis test at the 5% level of significance to investigate if there is sufficient evidence to dispute the company's claim. So we're going to test it and see if it's true or not. So first step in the procedure is to state the null hypothesis. So this is what needs to be tested, and that is H0. And it is saying that 20% of products experience problems in the first 5 years of use. So 20% is the figure we're testing. Or we can write it in mathematical terms. We can say that P is equal to 0.2, where 0.2 represents 20%, and P is the population proportion. Let's state the alternative hypothesis, H1. And that's saying that the null hypothesis is not correct. The proportion of products experience problems is not 20%, or more simply, P is not equal to 0.2. Now we're going to calculate the sample value P hat. So the sample said that 98 out of 400 products sampled experience problems in the first 5 years. So 98 out of 400, or 98 divided by 400, gives 0.245, which is basically 24.5%. Okay, so we have P hat, and the next step in the procedure is to calculate the margin of error, and this is for a proportion. Okay, and if you go back to the previous lesson, we had this definition for the margin of error. So it's the 1.96 root P hat times 1 minus P hat over n. Okay, and we're using this version. There was two versions, one with regular P, but we're using this version as P, the population proportion, is not known to us. Okay, so we're using the sample proportion. And there is our margin of error. Okay, putting 0.245 instead of P hat, and 400 is the sample size n. When you work that out, we get a margin of error of 0.048. So now we need to create our interval. So remember that the population proportion should lie between P hat minus E and P hat plus E. So let's put in the values we had for those. Okay, so we had P hat was 0.245 and our margin of error was 0.048. And that gives me an interval from 0.197 up to 0.293. Now let's recall the claimed value was P equals 0.2, or 20%. Does it lie within our interval? So does 0.2 lie between 0.197 and 0.293? Yes, it does. Okay. Thus, we fail to reject the null hypothesis. We cannot say the company was incorrect because 0.2 lies between the interval. So we fail to reject the null hypothesis. And the proportion of products that experience problems within the first 5 years could be 20%. We cannot say that it's incorrect. Okay, so there's a hypothesis test. We have another example for hypothesis testing, but with one difference. In this example, the statistics given refer to the means of the population and of the sample, not proportion. So you will see that we use a different definition for the margin of error when we're talking about means. The manufacturers of a line of batteries claim that they have a mean lifetime of 86 hours. A random sample of 200 batteries has a mean lifetime of 87.5 hours and a standard deviation of 11 hours. Does this provide evidence at the 5% level of significance that the batteries have a different mean lifetime to that claimed by the manufacturer? Okay, so we're going to do our hypothesis test, and the first thing we'll do is to state our null hypothesis. So what are we going to test? So the null hypothesis is the statement that the mean life of batteries is 86 hours. So H0 says that the mean life of batteries is 86 hours, or instead, if you wish, that mu is for mean, mu equals 86. Now we'll state the alternative hypothesis. Okay, and that's H1, and it's saying that the null hypothesis is not correct and the mean lifetime of batteries is not 86 hours, or mu is not equal to 86. The next stage then is to see what the sample says. Okay, so calculator state, and that was already calculated for us. The question told us that the mean from the sample, so x bar, is 87.5 hours. So the next step in the process is to calculate the margin of error, and here we're calculating the margin of error for a mean. And if you go back a few lessons, you'll see that the definition for the margin of error when we're working with means is 1.96 multiplied by the standard deviation over root n. Okay, so sigma is the standard of your deviation and n is the sample size. Okay, so if we put in our values for that, so we're told in the question that the sample has standard deviation of 11 and the sample size is 200. And we can calculate E there, and it's 1.52 when I rounded it off. So let's use that to create our interval. So remember that the mean will lie between the sample mean minus your error and the sample mean plus your error. So putting in our values for that, so the sample mean was 87.5 and the margin of error that we found was 1.52. And we get a confidence interval for the population mean. So it begins at 85.98 and goes to 89.02. So let's recall the claimed value was that the population mean mu was 86. Does that lie within the interval that we created? Started from 85.98 up to 89.02. Yes, it does. Thus, we fail to reject the null hypothesis. The mean life of the batteries could indeed be 86 hours as claimed by the company, and we cannot say that it is different. We don't have enough evidence. Now, just a note that there is alternative ways to test hypotheses. Okay, thus far we have created a 95% confidence interval using the margin of error, and we see does the stated or the claimed value fall within that interval. The alternative way you could do it would be to calculate a z-score for your statistic. Okay, using this definition for means. And if the absolute value of the z-score exceeds 1.96, so if it's more than 1.96 or lower than minus 1.96, then the statistic is significantly different from the population mean, so more than 2 standard deviations, and the null hypothesis should be rejected.